Welcome, everyone. Today, we are taking a journey that spans billions of years and light years across the cosmos. Right here from our, studios, I welcome you all. So, today we are diving into a truly mind bending concept, the profound and perhaps even direct link between the explosive death of distant stars, which is also known as supernova, and the very history of our planet, including the evolution and fate of humanity. It sounds like science fiction, but emerging evidence suggests that powerful cosmic connections that has shaped everything from Earth's climate to the trajectory of life itself. Prepare to have your perspective on change in this universe fundamentally altered as we explore the cosmic echoes, how supernova shaped Earth and humanity. To grasp this connection, we first need to understand the sheer power and nature of this supernova. Imagine a star, often many times more massive than our Sun, reaches the end of its stellar life. Its core collapses under its own immense gravity, triggering a catastrophic explosion. A supernova. This event is so energetic that for a brief period, a single supernova can outshine the entire galaxy, radiating as much energy as our sun will emit over its entire lifespan. So, this energy is released within a split second. These explosions are not just spectacular light shows, they are also cosmic forges where many of the heavy elements that makes up our planet and indeed ourselves are created and dispersed throughout the universe. Elements like carbon, oxygen, iron, all essentials for life, are born in the hearts of the massive stars and scattered by these colossal blasts. So, in a very sense, we are all made of stardust. But the impact of supernova can extend far beyond the creation of elements. The explosion also unleashes a torrent of high energy particles known as cosmic rays, as well as various forms of radiation. And it is the energetic byproduct that scientists believe may have played a significant role in shaping Earth's environment. Now, let's connect these distant stellar explosions to something as tangible as the Earth's climate. The hypothesis gaining their traction suggests that when a supernova occurs relatively close to our solar system, within a few hundred light years, the increased flux of cosmic rays reaches Earth can have noticeable impact on our atmosphere. One proposed mechanism involves cloud formation. Cosmic rays being charged particles and can ionize the air molecules in our atmosphere. These ionized molecules can then act as nucleation sites, encouraging formation of clouds. An increase in cloud cover can lead to more sunlight being reflected back into the space, potentially causing a cooling effect on the planet and even triggering or influencing an ice age. Conversely, change in atmospheric ionization and cloud formation pattern could also lead to regional or global warming in different scenarios. The intricate relation between the cosmic rays and atmospheric chemistry and climate is still an active area of research, but the correlation found in geological records are intriguing. Scientists look for evidence of past supernova events by studying isotopes like iron 60, plutonium 244, which are found in deep sea sediments and Arctic ice cores. These radioactive elements are not naturally abundant on Earth but are produced in significant quantities during supernova explosions. Finding spikes in concentration of these isotopes in specific geological layer provides a direct fingerprint of nearby star. And this stellar blast had occurred millions of years ago, allowing us to correlate these events with shifts in Earth climate. The impact of supernova might not have been limited to gradual climate shifts. Some researchers propose a link between these cosmic events and major extinction events in Earth's history. The sheer intensity of radiation from relatively close supernova could potentially damage the ozone layer, exposing life on Earth to harmful level of ultraviolet radiation. Furthermore, the increased influx of cosmic rays could lead to an increase in mutation in living organisms, potentially destabilizing ecosystems already under environmental stress. While a direct smoking gun link is still being investigated, the timing of some nearby supernova candidates with period of significant biodiversity loss on Earth is certainly a suggestive matter. Think about the late Devonian extinction or even more recent Paleo-oceanic megafauna extinction. Could these events have been influenced, at least in parts, by a cosmic trigger from a distant stellar explosion? It's a provocative idea that challenges our traditional understanding of what drives these planetary scale crises. Now let's bring this cosmic connections even closer to home, to the story of humanity itself. The subtle but persistent influence of supernova induced climate changes over millions of years could have played a role in shaping the environmental pressures that drove key moments in our evolution. Consider the period of significant climate changes in East Africa, where early hominoids evolved. Could fluctuations in temperature and rainfall, potentially influenced by cosmic ray activities, have spurred the adaptation, the development of new survival strategies, and even migration patterns? For example, the expansion of grasslands and the retreat of forests, possibly linked to long-term climate shifts, might have favored, things like people standing on two legs, etc., and the development of tools for hunting and scavenging in open environment. These are complex processes with many contributing factors, but the potential influence of distant stellar event adds a fascinating cosmic dimension in our own origin story. Furthermore, changes in radiation levels could have subtly increased mutation rates over long periods, potentially contributing to the genetic diversity within early human population, providing the raw material for natural selection to act upon. Understanding this link between supernovas and Earth's history compel us to consider our place within the vast cosmic neighborhood. Our solar system's orbit within the Milky Way galaxy. We know that a dynamic environment where stars are born and die in spectacular fashion. While the vast distance generally protect us from most immediate and devastating effects of supernova, the long-term influence of their energetic byproducts seems to be woven into the fabric of our planet's history. Scientists continue to research for evidence for past nearby supernovas and to refine our understanding of the cosmic rays interact with our atmosphere and biosphere. This research not only shed light on our past understanding but also help us understand the potential risk and influence of future cosmic events. From this fiery demise of massive star to the subtle shift in Earth's climate and grand narrative of human evolution, the evidence of cosmic connection is becoming increasingly compelling. Supernovas, once thought to be of purely astronomical phenomena, may have played a crucial role, often invisible role, in shaping the world we inhabit and very course of our history, right here on our pale blue dot in the vastness of the space. So thank you for joining me on this cosmic journey today, and I hope this exploration also broadened our understanding of the interconnectedness of the universe and our place within it. So friends, stay curious, keep looking, and remember that we are all part of the grand cosmic story shaped by events that unfold light years away. Thanks for watching, and I will catch you again in the next one, my friends.